Hey there, students. I wanted to do an example problem from Chapter 11 where we see how to do a goodness of fit in StatCrunch. So this is from homework number 14 on Chapter 11, and I grabbed problem number 5 here. The problem asks us to conduct a hypothesis test and provide the test statistic and the critical value and state the conclusion. And the problem says that a person randomly selected 100 checks and recorded the cents portions of those checks, meaning dollars and cents. The table below lists those cents portions categorized according to the indicated values. Use a 0.025 significance level to test the claim that the 4 categories are equally likely. The person expected that many checks for whole dollar amounts would result in a disproportionately high frequency for the first category, which apparently is 0 to 24 cents as the cents value on the checks. But do the results support that expectation? So we do see 0 to 24 is the highest value. There were 31 checks in that range, and the others were in the 20s. But again, that could have happened just randomly. So we want to test the claim or the suspicion that the distribution were not randomly distributed between the 4 categories, and that there was a unrandom distribution because there were more in the first category. So the first thing they asked us to produce right out the gate is the test statistic is what? Now there is a link here to view the chi-square distribution table, but typically we don't need to do that until we're finding the critical value. For the test statistic, we would just use the data directly in StatCrunch. So let me open up this in StatCrunch. So now they've put the different categories and the results in StatCrunch for us. And I'm going to go to Stat. And this is a goodness of fit distribution because we are checking to see the chi-square test, whether the data fits is a good fit to an equally distributed distribution. So I'm going to go to chi-square test. And so in the chi-square test, StatCrunch needs to know which of the data columns has the observed values in it, which is here. So it says observed and asks you to select a column. So I would click on number because that's the observed column. And then if you were not doing an equally distributed distribution, then you would have to have expected observations for what you thought the distribution would be. But if it's equally distributed, you can just put here all cells in equal proportion. Then you don't have to fill in what the different possibilities would be here. And that's it. So we tell the observations we saw were in the number column, and we're testing this to see if this is a good fit with all cells being in equal proportion. And I compute. So here's the results, and it does tally up. There were 100 observations. They even show you what the equal distribution would look like. The expected values, if there was 100 distributed equally in 4 categories, would be 25 for each. And here's what we observed. And then because there was 4 observed values, the degrees of freedom is 3. So the chi-square value is a nice even 2, and there's a p-value here as well. All right, so how do we interpret this in order to answer the questions? The test statistic is. So the test statistic is the chi-square value. So I'm going to take that 2, and it says round this to 3 decimals as needed. Well, 2 to 3 decimal places is 2. So it's happy with that. So then after that it says what is the critical value? So again, the critical value is the value you would need on a chi-square distribution to meet the significance level stated, which in this case was 0.025. And again, with the chi-square distribution, we also need to know that the degrees of freedom were 3, 1 less than the number of observations. Well, the critical value is not shown here. They actually just calculate the chi-square value and the p-value. So for the critical value, you want to use the chi-square distribution table, which they've linked to here just to make things easy. So that's nice. So if I click on this, here's the chi-square distribution table. And so what we want to do is find degrees of freedom at 3, which is the third line down, and then go for the column where we have a significance level of 0.025, which will be the area to the right of this value. So I have to scroll over here, and I want the third level. So I go to where I have 0.025, and I go down to the third level, because that's where degrees of freedom was 3. And I get 9.348. I'll copy that. And again, third level. Yes. So I'll put that in. Don't need that anymore. Check my answer. So that's how we get the critical value. And then we need to do the conclusion. So what's going on here? So the critical value is 9.348. What that means is that we would have needed our chi-squared value to be that value or above to have this significance level of assurity that we could reject the null hypothesis that these are just all equally distributed. And if it's not above that, then we can't. Or if you're thinking of the p-value logic, if the p is low, the null must go. The p-value would need to be below 0.025, and it's 0.5, which is nowhere near that low. So that means we cannot reject the null hypothesis. So let's go ahead and fill in this conclusion. We do not reject the null hypothesis. Again, the null hypothesis here would be that these are all equally distributed, and the alternative hypothesis is that they're not. But we do not reject that because this is quite possibly likely to have happened by random occurrence. There is not sufficient evidence to warrant rejection of the claim that the 4 categories are equally likely, because if they were, you would observe these kind of results more than 50% of the time. The results do not appear to support the expectation that the frequency for the first category is disproportionately high. They do not support that because this is perfectly in line with them all being equally distributed by chance. And so that's how we fill out the conclusion. Okay, so just a quick example to show how you can use StatCrunch for some of the things needed. Again, for the critical value, you could do that in StatCrunch, but they conveniently just give you a table where you can look it up right here, and that's a lot easier. So best of luck. Keep up the hard work. We're getting near the end.